Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. In this lecture, I will discuss the important concepts of permutations and combinations with examples. For this lecture, I am using the work of one of my best students, Miss Sayyida Fiza of class 2020, the Lyceum. An important advice for me and for everyone: we must always be careful. Permutations. It means orderly arrangements of objects. For example, AB and BA are two different arrangements, which is why in permutations BA is not equal to AB. And that is why 2P2 is 2, not 1. NPR. This is used for the arrangements of R distinct objects from N distinct objects. For example, if we have to arrange 4 letters from the 6 letters of the word Lyceum at random, we will use NPR. In this case, it should be 6P4. Types of questions in permutations. Together, next to each other, type 1, type 2, not together, type 3, alternatively, type 4, digit-based problems. These are some important types of questions of permutations. Together or next to each other means the same thing. And to solve these type of questions, we have 3 methods: box method, spaces method, counting method. Box method. In box method, we place our requirements in one box. We place our requirement, let's suppose here, and the remaining objects in the other box or boxes. We then first arrange the requirement and then arrange the remaining objects. For requirement, we write requirement factorial, and for remaining, we will write remaining plus 1 factorial. If remaining objects are 7 and requirement are 2, so we will write 2 factorial here, and 7 plus 1, 8 factorial. Plus 1 is because of this object, because requirement is always considered as a single object. So if we have 7 objects here, then with this one, remaining plus 1 will become 8 factorial. So this is the way to arrange the objects together by box method. For example, find the number of arrangement of all the letters of the word Singapore if the letters G, N and S are all together. We will use box method to solve this question. There are 9 letters altogether. So requirement is GNS, 3 letters. Remaining letters are 6. So we will write requirement here, and within this box, these 3 letters can arrange themselves in 3 factorial ways. Remaining letters are 6, so these are 6 objects, and this is 1 object. So altogether we have 7 objects, so it should be 7 factorial. 6 plus 1 makes 7. This is the logic of this 7 thing. See, remaining objects are 6. So 1, 2, 3, 4, 5, 6. We have 6 blocks here, or 6 boxes here, and this is 1 box. So altogether we have 7 boxes, and all objects can arrange themselves in any of these 7 boxes. So that is why we have 7 factorial here. NPR. I told you NPR is used to arrange R distinct objects from N distinct objects, where N can take all positive integers values, like from 1, 2, 3, 4. Maximum it could be 30, and R, it starts from 0, whole numbers. Example, find the number of different arrangements of 4 letters from the 6 letters of the word Lyceum. So we have 6 letters, we have to arrange 4, so we will use NPR, N is 6, R is 4, so there are 360 ways to arrange 4 letters from the 6 letter of the word Lyceum at random. We use this when we have to arrange less number of objects from n, and we use NPN or n factorial, they both mean the same thing. NPN or n factorial means same thing, and this is used to arrange all distinct objects. When you have to arrange all objects, then you should use this thing or this thing. For example, if we have to arrange all 6 letters of the word Lyceum, then we can either use NPN or n factorial. According to NPN, we should write 6p6. According to n factorial, we should write 6 factorial. We'll get the same answers because they both mean the same thing. So we have done the box method. Now we have to do spaces method. Steps. So these are some important steps to understand this method properly. The first step is first arrange the remaining objects. So according to spaces method, or while using this method, we first arrange the remaining objects by making blank spaces like these spaces. Number 2, we make the circular slots like this for the requirement, and make sure you always make one more slot with respect to these spaces because circular slots are always inclusive. Now fill the slot or slots according to the requirement. If there are 2 or more distinct objects in this slot, then arrange those objects as well like this. So we will understand this method through this example. The letters G and S are all together when all 9 letters of the word Singapore are arranged. So we have 9 letters in which we have to arrange G and S all together. So requirement is 3 and remaining is 6. According to this method, we will first arrange the remaining objects. We will make these spaces for remaining objects. So we have to make 6 spaces, 1, 2, 3, 4, 5, 6, because there are 6 objects. So 6 factorial for remaining objects. Now we have to make circular slots like these. There are 7 slots and we just need to fill one slot in this way. We have to place GNS into one slot, and we can place GNS into any one of the 7 slots. So 7p1, we have 7 slots and we have to fill just one slot. So we have to write 7p1. And within this slot, GNS can arrange themselves in 3 factorial ways. And this is step number 4. If there are 2 or more distinct objects in a single slot, then arrange those objects as well like this. So let me summarize this. First, arrange the remaining objects by making spaces for them. So there are 6 objects, so make 6 spaces and write 6 factorial. Slot will be one more than the number of spaces. So it should be 7. And you just need to fill one slot, any one slot with this requirement. So it should be 7p1. And since we have 3 letters in one single slot and all are different, so we need to arrange them as well. So we need to write 3 factorial in this case. So this is the spaces method. Another example, and you have to do this example yourself. This example is similar to the previous question. Find the number of different arrangements of all the letters of the word Singapore if the letters G and S are separated. Are separated or are all separated, they both means the same thing. I'm solving this question. So never use box method for this. Whenever you will find this statement are separated, then never use box method. Always use spaces method. So altogether we have 9 letters and the requirement is 3 letters and remaining letters are 6. So first we need to arrange the remaining letters by making spaces for them. So since we have 6 letters, so we must have 6 spaces. So 6 factorial for remaining letters. Now we have to fill 3 slots, any 3 slots out of 7. Because I told you slots are always one more than the remaining objects. If remaining objects are 6, then slots will be 7. So we just need to fill any 3 out of 7. So 7p3. And since we just have one single letter in each of these 3 slots, so we don't need to arrange them. We don't need to write 3 factorial or 1 factorial as we did here. We did this here because in one slot we had 3 letters, so we had to arrange all those 3 letters. Here we just have single letters in all 3 slots, so we don't need to arrange them. It's perfectly fine. So 6 factorial is for remaining objects. Slots are always one more than the remaining objects, so 7 and P3 because we have to fill any 3 slots. Counting method. It is used when there is a restriction or limit in the given space. For example, the back row of a taxi has 3 seats. This 3 seats is the restriction. So we cannot use spaces method here. We have to use this counting method. The back row of a class has 12 seats. 12 seats is the restriction. Now, let's understand this method through this example. Don't use the spaces method for these types of questions. Example number 1. The back row of a class has 4 seats. 1, 2, 3, 4. And you know seats are always adjacent. Two students, Maha and Zara, want to sit together. So there are two ways for them to sit together. Maybe MZ or ZM. So if you are using MZ, then you need to write 2 factorial here because they both can switch their places in these two ways, MZ or ZM. Now, this group have 3 possible choices to sit together. This is the first choice, this is the second way, and this is the third way. So there are 3 P1 ways for this group to switch their places. So you need to write 2 factorial for their arrangement, and then you need to count the number of possibilities for them to sit together. So this is the first possibility, second possibility, third possibility. So you need to write 3P1 here. And remember, there were 4 seats and we wrote 3 here. So this is always one less than this number. If we had 5 seats, then this would be the fourth possibility. Then it should be 4P1. So if there are 5 seats, then you have to write 4P1. If there were 6 seats, then you need to write 5P1 here. This number is always one less than of the given space. This example is very important. The back row of a class has 12 seats. These are the seats 1, 2, 3. All seats are adjacent. So these are 12 seats. 8 students want to sit at the back row. 2 particular students, Maha and Zara, want to sit together. Find the number of arrangements of all 8 students. This is so simple. We already have done a question of this type here. So for Maha and Zara, you need to write 2 factorial. And I told you if there are 12 seats, then it should be 11P1. There are 11P1 ways for them to switch their places as a group. So this is the first place, second, third, fourth, and 11th. So write 11P1 here. So this 2 factorial is for MZ to switch their places, to exchange their seats. And this means for MZ group to switch in 11P1 ways. Now we have 6 more students to arrange. And we have 10 empty seats. So we can write 10P6. And these 6 students can sit randomly. Well, if the question is M and Z are not together, if this is the question, then you have to do this first and then you need to use this formula. For not together, for MZ not together, use total minus MZ together. So total is 12P8 minus together. So with this way, you can solve this question. MZ are not together. So I'm completing this lecture here and finishing this lecture here, and I will discuss this permutation with repetition in my next lecture. I hope this first lecture will help you to understand the concepts of this chapter. Allah Hafiz.